Okay, today's problem is jump game. Jump game 3. Here it is mentioned, here it is given an array of non-negative integers. So they have given a position of start. What you have to do, we have to, like, when I am in that position, I can index y. I can jump to index next. What are the next index I can jump to I plus error of I or I minus error of I. And at the end, if I reach any index with a value of 0, then that means then this I can stop my jumping and return the true. So, but if I can't reach any of the index with value 0, that means uh, I return false. That is the question. So what is the constant, sir? Length is 500 to the power 4. Okay, fine. And error I, the value of error I is nothing but from 0 to less than error of length, and the start is always less than error length. So there is no edge condition like start is outside my index. So it is not a possible. Okay. Let's see a couple of examples to check what actually it wants to mean. So first, for this example, I am assuming my start equals to 5. So I am starting from here. At this place from where I can jump. So condition is 5 minus 1, that is 4th index, and 5 plus 1, that is 6th index. Okay, so there are two possible cases to jump. So let me draw it. This is the one possible case, and I am drawing in the blue line to the second possible case. Okay, first check it on one possible case. So I am going for this case. So this case there are two options. 4 minus 3, that is 1, and 4 plus 3, that is 7. Now 7 is out of index, so I cannot jump, but 1 I can jump from 4 to directly first index. Here I can jump. Okay, so what are the cases? Again there are two possible cases, like 4 1 minus 2, 1 minus 2 equals to what? Minus 1, out of index, I can't jump, and 1 plus 2, what is 3. So third index I can jump. So 1 2 I am jumping to third index, and here I can see like index like value is 0, so I can say okay, stop, my value is returning 2. This is the one. So if I go to this, in this place 6 cases, so 6 plus 2 is 8, out of index I can't jump. 6 minus 2, that is all, it is 4, and in this case I can jump to the fourth index, right? So here I can jump to the fourth index. Fourth index is fine. So what I can do here, 4 from here I can, like 8 is out of index, I can't jump. So 4 I can jump. 4 plus 3, I think what, 7. So I cannot jump. And you can see already, like 6 minus 2, 4, and you can see already like this is actually step from this is I have calculated for the fourth index, right? So fourth, 4 again the pattern will be the exactly same. So 4 I have to jump at 1, 1 I can jump to the 3. This is if I start from the 5. Let's see, like this is right. So let's see what can we do from the index of 0. If I start from index of 0, what are the possible cases? Index of 0, that means I'm starting from the index of 0. So now what I have to do here, index is 0. That means 0 plus 4 equals to 4, and 0 minus 4 equals to minus 4. So I can jump minus 4 or 4. 4 is out of index, so I can jump to the fourth index. Fourth index I can jump. Let's jump at the fourth index. And fourth index I shouldn't remove this calculation. Actually the path is exactly same. Here it is again collapsing at the fourth index. So if I come back here and just remove this and remove this calculation. So here I am saying I'm starting at 0th index. So 0th index, where can I go? I can go to 0 plus 4 and 0 minus 4. 0 plus 4, fourth index, 0 minus 4. Minus 4 index is out of index. But fourth index I have already calculated. This is the fourth index calculation. correct? So from fourth index I can go where? 0, 2 I can go directly 4, 4 can I get down to 1, and 1 can I jump that to 3. This is my pattern. So this is the way. Now let's see another example here, like if a is equals to 2. A is equals to 2. So 2 is my starting point. Starting point 2. From 2 where can I jump? From 2 I can jump 2 minus 2 is 0, and 2 plus 2 equals to 4. So both are the valid cases. So you can jump at the zeroth cases. And 2 is I have already done it, so I am marking this 2 as visited. Okay. So 2 is done. So let's start from 0. So 0 I can to 0 plus 0 minus 3. 0 minus 3, that is minus 3. Unreachable. 0 plus 3, not unreachable, it's a invalid index actually. 0 plus 3 is third index, so I can go to third. Okay, so let's draw as well. 0 I can go 0 and 0 to 3 I can go. Okay, so after that 3 from 3 where can, so 0 is also visited, is also visited. From 3 where can I go? From 3 I can go to where? 3 minus 1, that is 2, and 2 is already I started from 2 and it's already visited, so I cannot go to 2. And 3 plus 1 equals to 4. See, I have calculated my 4, right? I have calculated my 4, but I didn't visit it. So right now I can visit my fourth index, right? Right now I can visit fourth index, correct? So I can visit the fourth index, fine. So fourth index I can go 3 to 4 I can go. Now 4 to 4, 4 from 4 I can go 2 places, 4 plus 2, that is 6 out of index. I can visit 4 minus 2, that is 2. So I am marking 4 as 3 as visited, 4 as visited. Okay. So because 3 I have visited, 2 also like 4 I have also visited. So 4 minus 2, 2 is already visited, so I can't go. So I can't, from 4 also I can't go. This can't go, this can't go. So at the end it will return this 2 return false, this will return false, this return false. This by default return false. Before if it is out of index it will return false, or out of index or visited index it will return false. And here also it is written false. So this combine these two are both are returning false, so it will also return false. Now if it's false, it is false, so this case is also false. Now check this index. Now see fourth I have already visited here. Fourth I have already visited here. So this is also like if it is visited I will not visit again. So this is also false. So from this case I cannot reach any index with the value of 0. So what we could see, see, it is a kind of a connectivity problem, and you all know, like for the connectivity problem, we use BFS and DFS. This is what I am using actually for the DFS. Like I am visiting, I am staying on index position, then I am going to move forward to another index position, and from index position, that index position, I am again move forward until and unless I visit all the paths. Okay. Then I come back in the previous, like here also, like I start 0, 0 to 3, 3 to 4, 4 I have done every passes. Now I am coming back 3, 3 I have done every cases. So then I am coming back 2. Then from like not 2, like starting position. From starting position I can get like if both cases are done or not. This is what we do. So it's a simple BFS or DFS problem. So from BFS and DFS, what actually better thing to do? See, for BFS and DFS, both we need what? Both we need visited array to just check whether I am visited or not. And but what will be better if you can solve the problem for both by via BFS and DFS both? Better way is use the BFS, because DFS has a recursion stack, so it will extra memory space and extra it is much more complex. So that's why prefer BFS. BFS is simple loop, and it only contains only a single array visited. Okay. Okay. Let's then solve this problem. This only one problem, one case using the BFS. Okay. So let's start from the longer case, that is 5. Okay. So let's start it. Let's remove the BFS here. So BFS, you all know, for BFS what do you need actually? We need a visited array. So we need a visited array. I'm not using visited. Visited by default it is false. Consider it is false. Nothing is there means false. Consider it. And also we need BFS. I need a queue. Okay. So in the BFS, when we start the BFS, we need to input we have to include the index from where I am starting. So given starting index is 5. Okay. So I write the index equals to 5. So 5 I insert in the queue. So I mark this thing as false. Okay. So if I do this thing, now what are the possible cases from the 5? From 5 I can go to 5 minus 1, that is 4, and 5 plus 1, that is 6. Okay, so this is both are valid index. Both are, sorry, 5 plus 1, that is 6. Both are valid index. So I'll do what? I'll insert 4 as well and 6 as well. I pop 4, sorry, pop 5. Then I calculate this index position, like what will be my next target index, and then I insert 4 and 6. Okay, so this 4 is also marked as now. Sorry, my bad. It should not be false. It should true because I have visited the 5. This 4 is also now visited. 6 is also now visited. Now I will pop the fast. It's the queue, right? So I will pop 4 and 4. I will check 4 minus 3, like index minus ARR of index, right? So 4 minus 3 is 1, and 4 plus 3, that is 7. This is out of index. So out of index I don't care. So 1 I am going to insert here and mark this one as visited. Okay, so now I will pop what? I will pop 6. Now next element is 6. So 6 plus 1, nothing but 7. I can't go 7. And 6 minus 1, that is 5. If you notice, 5 is already visited. If it is already visited, I will not insert that index. Okay, so for 6 case, I will not be going to insert anything. Let's see for 1 cases. For 1, I can visit it minus 1. 1 minus 2, index minus 2, that is minus 1, that is invalid index, out of range index, and index 1 plus 2, I can go to third, right? Third index, yes. So I insert 3 here and mark that thing as visited. Okay, now you can see whenever I'm inserting, like whenever I'm popping out, I have to actually check like whether that value is containing 0 or not. It is not containing 0, right? So that means it is not it is, sorry, here it is contains 0, that means I'll return true here. This is the concept of this problem. Okay, let's write this pseudo code of this problem. So we are given a function, let's say jump 3. What is given here? Array is given. Okay, let's solve the problem. What is I need the length of the array as usual. So arr dot length. What is the other cases? Other cases I need what? For anything I need a visited array. So visited array of what? Array of size n. So visited of array size n, and I'm marking those things as false. Okay. What are the cases? What another thing I need? I need a queue. Queue is nothing but queue. Okay, and at the end, what step I have to do? As I told you, I have to insert. Okay, that start is also given. I forgot to mention start is. One start index is also already given. This is the start index. So what I have to do? Q dot add. What I am inserting? Start index. So that means what? Start is visited. So visited of start equals to true. Okay, let's now. What is my condition? Until queue is not empty, then till then I have to do the loop. So while not while queue is not empty, queue dot is empty, until it is not empty, I will iterate the loop. What I have to do in this loop? First I have to pop it out. So let's say index, I will get what? I will get one index position. So index equals to q dot pop or front, whatever the function method is. And after that, what I have to check? I have to check if my, what is that, ARR of index is equals to 0, isn't it? If my ARR of index is equals to 0, if that is the case, then what we will do, I'll simply return true. Return true. If I reach any case where I can, it is value is 0, index value is 0, then sorry, at the index the value is 0, then I can tell the true. What I can do, if it is not the case, then I have to insert is possible cases. So to get the possible cases, I will calculate the two value. So left, on the left, where can I go? Index minus ARR of index, and right arrow can go index plus ARR of index. Correct. So now I have to check, like this will be the my next index and next left right combination. So what I have to actually check it here actually. So again I have to check if my left is in the range, left is greater or equals to 0, then only I can go right. And my visited is not visited, is equals to visited of left is equals to false. If that is the case, then only I can go to the left index, isn't it? So when that is the case, then only I can write it, and I can say you can add in the q dot add the left index. And as I am adding the left index is already visited, that means so visited of L equals to true. Correct. Similarly, same thing I have to do. Same thing I have to do for what? My right side. If my right is less than n and n, if it is there, and visited of right is also equals to false, then only I can go that place. So I can go q dot add of r, and I will be mark this r as visited equals to true. This is the case. Simple. Now what? This loop will end. If the loops end, and that means what? We didn't get any case where I can get this, like any index position or value is 0. That means if I loops end, I'll say return false. That means I didn't get any case where I can get a valid case. That means index is 0. So this is the case of my what is called my BFS code. Okay. If I convert the same thing in the BFS, what could we do? So function, let's say jump3 ARR, and start. Correct. ARR and start. And if that is the case, so what I have to do? I have to do two things, like A and visited I need. No matter what, I need these two, like A and visited. Okay. And I will mark, like I have to call this function, like let's say function name is DFS. I have to call the function and return the value of the function. This function will return true or false. So I can directly return. So return whatever the value is, return the value. So return my DFS of start. So start. So as I am passing the start into the DFS, that means start is already visited, right? So I have to also mark this start as visited. I also already have to mark this start as visited. This is the case. If your DFS can take global variables, then you can give only start. Otherwise, you have to give many things, other things as well. Like start, you have to give ARR, you have to give, let's say length, you have to give, and visitor also you have to give. Pass it. Okay, and this is all. And let's write the function for DFS. So function for DFS, and it is nothing but start ARR in. It is up to you. You can pass in or you can calculate in. Doesn't matter. And what are the cases here? So first case here also I have to check one case like if it is index is 0, if my let's say mark is at not start, I'm passing if it is index IDX. So here also I have to check if my index is actually 0 and sorry value of the index position is 0. And I can simply write the same code. This is the code, correct? This is the code I will calculate. If it is true, return true. Okay. So another case, like if it is not 0, then what I have to do? I have to check whether it is next index is valid index or not. In DFS you can do two things. Either you can check the it is a valid index or this kind of cases earlier, then you can pass the scenario if that is the case. And if you don't want to you have to inside when you can pass everything, and inside here you can check whether that is a valid index or not, a valid case or not. So I want actually before inserting, I want to check like whether it's a valid case or not. Okay. So for that, what I have to do, I calculate LNR as usual, what I did earlier. Same thing. This is how you can write from convert DFS to DFS. This is the case. I can check. Now I have to check this case if it is a valid case or not. Correct. So I will check it is a valid case or not. Not copy. Even copy. Like as always, like I'm not copying it. Let's copy these two cases as well. This is the thing we have to copy, right? Copy. So this is the two cases I have to copy. If it is visited or not. So if it is, let's say, fast case, I have to check fast case. Assume like here, think of it. Here you all know like what I have to do. If those are valid cases, I have to check whether two cases are valid or not, right? Two cases are valid or not. So here I have to check what I have to check. Like I have to do what I have to do DFS and this L, then pass all the things like ARR in and visited. This I have to do, and here also DFS L ARR, sorry, not L, R, R, ARR, in and visited array. Correct. So here are two cases are there. See, if I already calculated this case, if I already calculated this case and it gives us true, should I check for this one? No, right? So if I already calculated this, and if if it is not giving us true, then only I have to check this one. If it is giving us true, then it is not should not give any check, right? So what I will do, I will check if this is the case, because this is giving us true or false, right? If this is give us true, I will return true, return true. See, and I can simply return this because see, like if my fast recursion this call doesn't give us true, then all depends on second call. Second call gives us either true or false. If it is true, then overall value will be true. If it is false, because this will return true, this is not giving return true. So if it should like this function should return true or false. So all now if it is give us the return true, that means it is not getting called and it is simply return as true. But what if it return false? If return false, then I have to check this one. If it is true, then I will return this function should return true. If this gets false, this function return false. So what I can directly write return this directly. I can return this directly. Return this directly. Or if you wish, simplify. If you don't get it, no worry. You can check like as previous. If that is the true case, then return true. If that is the true case, then return true. Return true. And here at the end of it, like if everything is done, and then here return false. Return false. Why I'm return false here? Because if it is return already true, then it should have written in these cases. These three cases it should return true. Otherwise it should return false, right? That's why I return the false. And obviously one thing we have missed here. Like if I am passing this L, so I have to already mark, I have to mark now this L is visited. So mark L visited equals to true, and here also you have to visit it of R equals to true. As similar we do. So earlier we are marking visited true is after inserting the Q, right? So it doesn't matter. You can mark insert before, mark this true as true before inserting the Q as well. So this is, you can see, the same pattern I am following to convert DLS to DLS. So this is all. This will give us the solution. So yeah, this is the case. Let's see the time complexity of this code. We all know, like, time complexity of BFS or DFS, in any cases time complexity is big of like number of node plus number of edges, right? So here what is the number of nodes? So here for simplicity we can say we're visiting each and every index of the array. So this is obviously big of n, correct? And here also in the DFS also we are inserting and checking whether uh, that every each possible of the nodes. But see here you can say like we are doing twice. We are checking twice, right? But no, check here. Like, yeah, there is another concept. Like, if it is a false, then only I am visiting. If it is a true, then I will not visit. Then I will not visit, right? So this is the case. So this BF is also big of n. And what is the ages? It is the maximum how many of ages will be there. Maximum how many of ages will be there. I am considering each ages will be the valid ages. Okay, ages is the valid ages. So let's assume length of 5. Okay. So anything at this first index and last index, it has, like, it will be whatever the value will be. So 0 minus something x something x. So this obviously this is out of index. So it has only one possibility. Similarly, here it is n minus 1 plus x something. So this x will be also like only one possibility. Apart from that, every possible case has two possibilities, right? So I am just assuming. So anyhow, we are just check, like, if I had two possibilities, it has two possibilities, it has two possibilities. So how many times? Like n minus 1, like number of nodes minus 1 into 2 edges. This is nothing but n, right? Nothing but n. So this is also n. So overall time complexity is big of n. Time complexity is big of n. Space complexity, we are taking extra index for my space visited array, right? So space complexity is nothing but also big of n. Yeah, that's all. As always, if you find any mistake in this video, please let me know. And if you find any information on this topic, also let me know so that I can learn. Okay, bye bye.